for this problem, we need to factor the trinomial into two sets of binomials. Since there isn't a common factor between the s squared, the 16s, and the 63, we can't factor out a common factor. So our end result is going to be two parentheses, and then within each parenthesis we're going to have a binomial, which just means we'll have two terms either being added or subtracted within the parentheses. So factoring the trinomial kind of undoes the FOIL method. If you remember, if we have two sets of binomials here, and we want to multiply them together, we use the FOIL method. So that just means that we multiply the x times the x, and then the x times the 3, and then the 2 times the x, and lastly the 2 times the 3. So we would have x squared plus 5x plus 6. So for this problem, we're taking something that looks like this, and we're rewriting it into something that looks like this, into the two sets of binomials. Okay, so there's a couple different ways that we can do this. I'm going to show you the AC method. This method seems to be the easier method, and again, it's called the AC method. And the first step is to identify the A and the C. So we have a quadratic in the form of ax squared plus bx plus c. The A is the number in front of the x squared term, or in this case, the s squared term. So we really have an imaginary 1 here. So our A is 1, and then our C is the constant term, or the term without a variable next to it. So that would be the 63. Next, you multiply the A and the C together, which will give us 63. Now we want to write the factors of 63. So we have 1 times 63. 63 is not divisible by 2, so we can't list that down. 63 divided by 3 is 21, so we have 3 and 21. And then 63 divided by 4 we can't do. 63 divided by 5 we can't do. But we can do 63 divided by 7. And then we can't do 63 divided by 8, so we're back to 9, which is here. So we know that we listed all the factors. So all I did was I started at 1. On my calculator, I divided by 2, 3, 4, 5, 6, 7 to see which ones went into 63 evenly. And then since I restarted at 9, I know that I listed all of my factors of 63. Okay, now that you list all your factors of 63, we want to find two factors that when added or subtracted together give us the middle term of 16, a positive 16. So I can take a positive 7 and a positive 9, and when I add those together, I get a positive 16. So that means I'm going to choose these two numbers to go in my set of binomials. So here I'll just create a template of my binomials. And in the first position of each binomial, I'm going to have the s, because s times s gives me the first term of s squared. Next, I'm going to select the factors that I just found, the 7 and the 9, and I'm going to place them in the last position of each set of parentheses. And since I need a positive 7 and a positive 9 to give me that positive 16, I'm going to have two plus signs here. So this is my answer. This is my factored form of the trinomial. To check this, we should FOIL it out. So we can multiply the first terms together. That would give us the s squared. The outer terms together, that would give us the positive 9s. The inner terms would give us the positive 7s. And then the outer terms would give us a positive 63. Then when we combine the middle terms, I get the positive 16s. So I'm left with the s squared plus 16s plus 63. Since this equals what I started with, I know that I factored this correctly. So again, my answer that you would type into my math lab is parenthesis s plus 7 end parenthesis, and then parenthesis s plus 9 end parenthesis. So that's your final answer.